When we talk about polynomial function, it is a must to mention that it is a defined function and continuous. That is, no breaks, no holes, no gaps or sharp corners. The highest exponent is the degree of the polynomial. So n is the degree, and an is the leading coefficient. The first part of the lesson, we're gonna talk about the end behavior. Two things determine the behavior of the polynomial: the degree and the leading coefficient. So part A, if n is even, that is 2, 4, 6, etc., then it depends on the leading coefficient. If the leading coefficient is positive, then the end behavior of the polynomial function are ending the same, either both up or both down. Positive, then they are both up. If an is negative, then both are down. Second case, if n is odd, also we look at the leading coefficient. If the leading coefficient is positive, then one arm up, the right one up, and the left one down. If the leading coefficient is negative, then the left one is up and the right one is down. As an application, let's have the first question, 3x4 minus 5x2 minus 1. The highest exponent is 4, so the degree is 4, which is even, and the leading is 3, which is positive. From this information, we should conclude that both arms are up. So the end behavior is limit when x goes to plus infinity. Look at this part, when x goes to plus infinity. The arm is going up, which means plus infinity for the y. So the answer is plus infinity. When x goes to minus infinity, we look at the left part where x goes to negative infinity, and the end behavior of the graph is going up, so also plus infinity. The second question, the highest degree is 7. So degree is 7, which is odd, and the leading is -2. That is negative. This information allows you to conclude that the graph is one arm up and one arm down. Which one going up? The left arm. So limit when x goes to plus infinity, and limit when x goes to minus infinity, to the plus infinity, the arm is going down, so minus infinity. When x goes to minus infinity, the arm is going up, so plus infinity. The last part, the greatest exponent is 3. So the degree is 3. And the leading is 1. This is odd, and this is positive, which means that the right arm up and the left arm down. So limit when x goes to plus infinity. So let's have a look at the positive infinity of the x-axis. The arm is going up, it means plus infinity. Limit when x goes to minus infinity. The negative part of the x-axis, when x goes to minus infinity, the arm is going down, that is negative infinity. The second part is zeros and turning points. Zeros, which is the solution of the function, can be determined from the degree. So if you want to find the zeros, at most it has the same degree. So at most this function has 3 zeros. The turning points, it is the same as the degree minus 1. So 3 minus 1. So it has 2 possible turning points. Now how to find the zeros? We're gonna solve the equation. Negative 2x squared, 2x to the power 3 minus 4x2 plus 16x equal to 0. To find the zeros, we have to put the equation equal to 0. We're gonna find the zeros by factoring. To factor it, the greatest common factor is negative 2x. Open bracket to see what's left. Negative 2x3 divided by negative 2x is x to the power of 2, and then plus 2x, and then minus 8 equal to 0. We factor it more. This is a quadratic trinomial. To factor it, I think about 2 numbers. When you multiply them, the product is negative 8. When you add them, the sum is positive 2. The 2 numbers are positive 4 and negative 2. When you multiply them, you get negative 8. When you add them, you get positive 2. And here we put x and x. It's factored now, we can start finding the zeros. according to the zero product property, the first factor is equal to 0. The second factor is equal to 0, or the third factor is equal to 0. From here, divide by -2, divide by -2, then x is equal to 0. From here, x equal -4. From here, x equal +2. These are the zeros of the function. For the other question, the degree is 5. So if you want to find the zeros, at most it has 5 zeros. The turning points, the same as the degree -1 at most. To find the zeros, we're gonna solve 3x5 minus 18x4 plus 27x3 equal to 0. Also, we're gonna think about greatest common factor. The greatest common factor is 3, x to the power 3. Three and 18 and 27, they divide by 3. X to the power 5, x to the power 4, x to the power 3, they have common x to the power 3. Open bracket. See what's left. 3x5 divided by 3x to the power 3 is x to the power of 2. Minus, if you do divide, you're gonna get 6x plus 27 divided by 3 is 9 equal to 0. We're gonna factor it more. 3x to the power 3 quadratic can be factored by open two parentheses, x and x. Think about two numbers. When you multiply, you get +9. When you add, you get -6. The only possibility is -3 and -3. When you multiply, you get +9. When you add, you get -6. We're gonna solve the first one, 3x to the power 3 equal to 0, or the other brackets, they are the same, so we're gonna take one of them, x minus 3 equal to 0. Divide by 3, we're gonna get x3 equal to 0. To get rid of to the power 3, we do cubic root, then x equal to 0. The other one, x equal 3. The last part is how to graph polynomial. Part we're gonna apply the leading term test. We're gonna find the zeros and the multiplicity and repeated zero. So let me stop at multiplicity and repeat 0. Multiplicity is how many times the zero or the solution is repeated. And what is the benefit of multiplicity? It tells us the graph crosses the x-axis or the graph tangent to the x-axis at this point. When we start, we're gonna talk about it in details. And then we find more points that allow us to graph perfectly. So we're gonna start putting the function equal to 0, from which we are able to solve it. Again, according to zero product property, they are in the factored form, so we can say the first factor is equal to 0, the second factor 2x plus 3 equal to 0, and the third factor x minus 1 is equal to 0. The first one is done, x equal to 0. The second one, when you transpose 3 to the other side and divide by 2, you're gonna get x equal negative 1.5. And the last one, x minus 1 equal to 0, so x equals 1. Now we're going to talk about the repeated zeros and the multiplicity. Look at the power of each factor. So x here has degree 1. The second factor has power 1. And the third factor has power 2. The one that has power 1, it means the multiplicity is 1. For the last factor, the multiplicity is 2 because the power on the bracket is 2. So x equal 1, the last one, has multiplicity 2 because of the power on the bracket. So what is the benefit of the multiplicity? The degree is 2. The multiplicity is 2, which is even. If the multiplicity is even, that tells you at this point the graph's tangent. It doesn't cross the x-axis, just tangent. The multiplicity is odd, let's say 3 or whatever. At this point, the graph crosses the x-axis. Okay. So let's talk about the end behavior now. As we mentioned earlier, the end behavior depends on the degree of the polynomial. Now our question is given in the factored form. So we need to multiply the brackets to expand and then multiply to get the last answer to find the degree. I say this is not important. What we do is the first factor, x to the power 1, no problem. The second one has degree 1. And the third one, the degree is 2. So I say from here we can get x to the power of 2. And from here x to the power 1. And already here x to the power 1. So if you multiply them, we're going to get x to the power 4. Regarding the leading coefficient, from here, the coefficient is 1, and here the coefficient is 2, and here the coefficient is 1. Multiplying the coefficients, we're going to get 2. And this is what we need. The rest we don't need it. Degree is 4, even. And the leading is positive, which means that both arms are up. So limit when x goes to negative infinity of the function f of x is equal plus infinity, limit when x goes to positive infinity is also positive infinity. So both arms are up. The only thing left is we're gonna take some special points to know exactly where the graph or the turning points are. This can be done by doing the number line positive infinity, negative infinity. We have x equals 0, x equal negative 1.5, and x equal 1. Arrange them in order. So negative 1.5 and 0 and x equal 1. I'm gonna take 1 point in this interval. Let's say negative 2. And in this interval between negative 1.5 and 0, let's say negative 1. And in this interval between 0 and 1, let's take 0.5. And in the last interval, we're gonna take 1.5 or 2, whatever. To find the y's, I need to replace in the main equation. F of x equal x into 2x plus 3 into x minus 1 to the power of 2. So let's replace negative 2. The first one I'm gonna do it in details. Negative 2, 2 into negative 2 plus 3 into negative 2 minus 1 to the power of 2. If you do some calculations mentally or using calculator, the answer will be 18. So the first point is negative 2, 18. For the second point, if you replace negative 1 by the same way, you're gonna get negative 4. So the point is negative 1, negative 4. The third point, 0.5. The y will be 0.5. And the point is 0.5, 0.5. The last point, 1.5. And the y is 2.25. And the point is 1.5, 2.25. The last part is draw the x and y axes. Okay, the first thing, I'm gonna put the zeros we found at the beginning. Zero, negative 1.5, and 1. Zero, negative. Let's say this is 1, this is 2, this is 3. Negative 1.5 is here. And 1 is here. The points we found, -2, -2 plus 18, so -2, 18, 1, 2, 3, 4, 5, 6, 7, 8. Let's say here -1, -4, (0.5, 0.5), and 1.5, 2.25, 1.5, 2.25. And before you start graphing, remember this information. The graph is tangent at x equal 1. And from the end behavior, we mentioned that both arms are going up. So to the left, passing it through 0, and this is 1 tangent and then goes up.